Physics Lab 3. The purpose of this lab is to model gravitational forces on a star trajectory that we calculate with our emails and to solve for the mass of the black hole that the star is orbiting. In part 2 of the lab, we want to figure out initial velocity that a starship needs to have in order to escape some kind of black hole without running into the black hole or the planet. The models that we use are the gravitational model, velocity update model, position update formula, and the definition that dp over dt can be broken into parallel and perpendicular components. I've written all of the formulas right there. We also use the fundamental principle that we've used in every other lab so far, that the change in momentum over change in time is equal to the net forces. And the main results of the lab we find in part 1 and part 2 is that the mass of the black hole that my star trajectory is going around is 1.42 times 10 to the 34th kilograms, so pretty large. And the escape velocity is negative 4 e to the 7th meters per second and 3.55 e to the 6th in the x and y components, respectively. So the lab setup, at some point we look at the ship, the sun, or the planet, depending on what part of the lab you're in and which forces you're looking at, because you look at both the ship and the planet in part 2. If you're looking at the ship, the surroundings is everything else, especially the sun and the planet. And that's the same for the sun and the planet, where the sun would be the ship and the planet would be the ship and the sun. So, the initial conditions is that the ship starts from some velocity that we need to find with trial and error, and the gravitational forces acting on it come from the other two objects and the surroundings that we use our fundamental knowledge of physics to find. From the code, the first several lines start with just given constants, like the gravitational constant, mass of the star. Those are all given to us. And then we use the very basic definitions of momentum and definition of change in really anything, with final minus initial being that. And the definition of dp over dt, which is change in momentum over change in time. Then we get into the Newton's second law, where F net equals dp over dt. And this stays true where F net in the parallel component stays equal to dp over dt parallel component, and same for perpendicular. Lines 176 also uses that dp over dt can be broken into parallel and perpendicular components added together, but we just rearrange that in order to solve for the perpendicular component. And then finally, we use all of this forces that we've calculated using dp over dt in order to solve for the mass of the black hole by rearranging the gravitational model that I mentioned earlier. So the results, as you can see, I mentioned earlier, the mass of the black hole is 1.42 times e to the 34th. For the part 2 code, we use the same process twice for both the planet and the ship, where we start off with the first other object in the surroundings, the black hole. We calculate the gravitational force acting on it with finding r hat, the magnitude of r, all of that, and we plug it into the formula I mentioned earlier. We did the same thing for the ship to find its gravitational force on the planet. We add the ship and the black hole's force on the planet to get the total F net on the planet, and we repeat that same process but with the ship this time. And then for the last several lines, we just use the velocity and position update formulas in order to make the move. And as you can see at the top here, once we run that a few times and do some trial and error, we can find that the ship speed is negative 4 e to the 6th and 3.55 e to the 6th in the x and y components, respectively. Here's a picture of my results. And for the conclusion, we can see even though F net and dp over dt are equal to each other in value, they aren't technically the same thing definitionally, where dp over dt is change in momentum, with a parallel component showing us change in speed, and perpendicular component giving us a change in direction, helping it turn in a circle instead of just shooting in one direction. And F net is the forces that are causing this change, like gravity that we've looked at earlier, where gravity is causing it to orbit around the black hole. And if we want the ship to orbit around the black hole, like I just mentioned, the velocity would have to be negative 4 e to the 6th and 3.55 e to the 6th in the x and y components, respectively. Thank you for watching.